SUSE.io makes security tools for everyone. SUSE's flat rate pricing means you can set up SCA and DAST tools for your whole team. No seat counts, no scan limits, and you never have to talk to a salesperson. SUSE integrates with all common CI/CD platforms and supports most popular package managers. And thanks to SUSE's open source vulnerability scanner, license management suite, and SBOM generation capability, you can get back to what you really want to be doing, coding in no time. Visit securityweekly.com/SUSE. Welcome back to Application Security Weekly. We just talked with Dr. Chenzi Wang about shifting security to developer tools and to boardroom conversations. I'm your host, Mike Shima, and I'm here with John Kinsella, and it's just about time for the news. But first, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to, of course, subscribe on any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. Then you can join Paul Asadorian and Rich Mogul on May 4th to learn how to choose the right architecture for your application. Live attendees will have the chance to win a $100 Hacker Warehouse gift card. Register at securityweekly.com/webcasts. Plus, don't forget to check out our library of past on-demand webcasts and technical trainings at securityweekly.com/on-demand. Mr. Kinsella, we both picked out a Java-related news article this week, and I was trying to come up with my clever puns, because I do enjoy sneaking those in every once in a while, and talk about Java ECDSA, and it could be all for naught and I wasn't sure if we want to go from hero to zero, from zero to hero, or it has been 0 days since a Java vuln. But
I'll just along that curve.
Oh, man, there we go. I didn't even think of that one. So maybe I'll give you first strike to talk about this particular vuln in the ECDSA implementation.
Yeah, Java's not having a fun year. So this is what's interesting? Okay, so we'll talk about what it is and then sort of dig into the interesting, at least to me, part about this. So the TLDR is in Java. Man, their version numbers are driving me crazy. I think it came out in 18, right? Yeah, so it was a relatively recent update to Java, which is the interesting part. I'll come back to that. But in this, I just saw that sorry, 1 second. Sorry with the dead air. I just realized that they put an update into this page since the last time I looked at it. But anyways, what's going on is they, as part of updating some of their crypto code, and the crypto nerd over here, Mike, can jump in and correct me when I get this wrong. But as part of updating this, they rewrote part of their the crypto code for elliptic curve from C++ into Java. As part of that, one of the key things you have to do, this is code around validating a signature on a signed amount of data with elliptic curve. There's 2 components to that, an RNS, which are part of that public key, which are used to do the math. And there's a particular mathematical, situation where I believe there's division going on between these two, right? Those 2 RNS are used to to calculate a part of the signature, and this Mike's going to get in here pretty quickly. But part of the RNS are used to come up with part of the, I'm forgetting my words, but the actual number which you're going to be comparing against the signature. Mm-hmm. But there's a particular situation in here where if both R and S are 0, that means the multiplication is going to go through, is going to multiply out of 0. So you're going to get 0 equals 0. In theory, people would think you might get a division by 0, but that's actually not the case. But what that means basically is if you craft really any type of data that goes in there that should be assigned data, and you submit it with a public key that has those 2 components, it looks like 0, you can send any data through and it looks like it's being signed. Is that accurate so far?
Yeah, and I think you hit the key part there. Is that those 2 aspects of the signature RNS, once those factors are 0, when you're trying to verify the signature, the multiplication, your multiplicative inverses eventually come out to be, as you said, 0 equals 0. And part of the spec to avoid this particular problem, it says quite explicitly, R and S are supposed to be integers, countable numbers that are greater than or equal to 1. And that's definitely not the case here. So that's one of the things that happens. So I think you might want to, maybe I'll throw back over to you, see if that's the, to pick up from there, if that's the path you were headed.
Yeah. So, and it's okay. So, there's something happened with some sort of crypto thing. I'm taking it back up high level and, doing the John hand wave. Some sort of crypto thing happened that means people can send data through, and it, where this becomes a problem is you start thinking about all the things which are signed using elliptic curves. So TLS data, JWTs, SAML assertions, OIDC for those still using those, WebAuthn keep becoming more popular. I heard a few more out there. I believe I heard people talking about some of the implementations of NFC, I believe also, if it's Java-based, might have issues. So this has a pretty wide-ranging thing. And everyone's like, how did Oracle only gives us a CVSS of 7.5 when it's like, oh my God, you're losing the ability to validate a cryptographically signed package or packet that's sort of important. But really it comes down to, and I did this last week, if you play with CVSS calculators, CVSS v3 calculator, just Google it if you're not familiar, you can actually punch in all the vectors off of the CVSS score which Oracle came up with. And since there is, oh man, now let's see how my memory is. Since there is not actual compromise to the system, and it is not compromising data which is nearby, it's just directly with the data which is being sent, that brings the score down from a 10 down to around a 7.5. I think it brings down from a 9.8 to about 7.5, if I remember right. But so that's the actual issue itself. The interesting part of this to me, it's Mike, we talk often about rewriting something to make it more secure, and I put my manager hat on and say, well, usually there's costs associated with that and other bugs. If something's working, don't fix it. And this is the example of that. So this was in C++. It was perfectly fine for many years. When they rewrote it, they forgot to put that check in for RNS being equal to 0. And here we are. So I think that, I can't remember when that commit was. It was relatively recent. But that's sort of this isn't something that's been there in all time of Java. They went through, I'm not sure, performance reasons. It must be can't be performance reasons. It must be for something else, having native code, I'm guessing, that they rewrote this from C++ into Java. It wasn't somebody was bored. There was a reason for doing this. But the result of that is they left a key part of that algorithm out, and so here we are. So this is sort of the problem when you touch something that's already in there. How do you make sure your tests are complete and getting all these edge cases?
Yeah, you hit the exact aspect of this article that stood out the most for me was that refactor, because in principle we like to just say from call it a non-practicing perspective, just here's the advice: rewrite away from a memory unsafe language like C++ into a memory safe language like Java, or we've talked about this with Rust. The Linux kernel, we're going to talk about that in a little bit, is rewriting some of its drivers in Rust, and these refactors, as you pointed out, sound great in theory, but they do have a cost. And some of the costs that are highlighted from this are that refactors are often important to preserve compatibility, preserve seamless functionality. So when we're going from the C++ implementation to the Java implementation, a lot of your testing is going to be positive testing. Does this signature still work?
Yeah.
Do we still decrypt, encrypt, these types of things? But that refactor then, as in this case, can very easily miss the failure modes or those abuse cases, or just what are the negative tests that I should be looking at. And in this case, it's not like these negative tests don't exist. There's the project Witchproof that I linked to in the show notes. It's also linked to in this particular article. It's a great test battery of all the things that could go wrong within a encryption algorithm, ECDSA, as well as many others. What was interesting is that that out of the box, Witchproof wouldn't run against this particular implementation. So it still needed some love and caring, so to speak, to make Witchproof proof apply to this? And who knows, maybe that is also one of the engineering trade-offs to say, we could have used this, but it's going to be a little bit more engineering to set up our test harness to test these negative cases. But the risks around crypto implementations probably should have very much outweighed that, or at least have maybe even just an awareness aspect that we need to be testing a lot more of these negative cases when doing this type of refactor.
And that's, I think, also an interesting thing to think about. And I hadn't thought about it till just now, but from the point of view of, we think about, okay, we're going to go write something new. If we take a moment to pause nowadays, we usually go, hey, has someone written this widget already? Can we either bring in one of those libraries from one of these third-party repos? Is there a container image that does this, or an open source project? Is there some way we can get this so it's a little bit less for us to write? Should we be thinking about that on the testing side? If we're coming up with some sort of new functionality that supports, I don't know, let's say, hey, it's a web server. Should we be going and looking to see, hey, is there an open source library out there, a test suite that we could actually go and point at our thing? I don't know of a collection of those, like a website that says, hey, here's, the way we have an awesome X for Wallace, or like an awesome unit test suite out there. That could be sort of interesting.
Yeah, it'd be very interesting. It'd be very curious. This goes into that aspect of, can you also write the code to be more fuzzing friendly? Which again, also of course has its own, engineering investment and security investment time to take care of. But I think that is part of the spirit of what are good test cases to run. Project Witchproof as one example for the crypto environment, and then could you also do some more mature, some more advanced stuff around fuzzing? But we're going to shift from still talking about Java, just because there's a whole bunch of articles for us to get to. Speaking of Java, in this case with ECDSA, they were talking about versions 15 through 18 were vulnerable, but don't even use 15 or 16 because they're deprecated. You shouldn't be on them. But of course, as we saw with Log4j and Log4Shell, a lot of people are on unknown versions of Java that were they vulnerable? Were they not vulnerable? And there's an article from Palo Alto Networks talking about a hot patch that AWS used to help to fix a lot of the Kubernetes clusters that were running within their ECS or Fargate environments. And unfortunately, this hot patch was intended to help customers, intended to help address Log4Shell, but opened up a pretty serious backdoor because it basically said, is there a process called Java that's running? If so, I'm going to drop in, I'm going to execute this hot patch solution to fix up that Java process, and I'm going to do it as root, and oops, I forgot that this was running inside of a container, and rather than keep it a containerized, restricted process, I'm just going to basically give it root uncontainerized, to hand wave a little bit, version of the process, which eventually turns into, account takeover, or system takeover, or bad things, trademark, copyright registered, for that particular container. So a really cautionary aspect of that hot patch approach when trying to talk about how do we deal with complex environments, complex issues when people are running old software, legacy software, just even aren't sure what version they're running.
Yeah, this is a good road up. It's sort of funny tying back into our guest. This is probably coming from Chensi's last company, or previous company, Twisthawk, now part of Palo Alto. That would be our previous guest from the last half hour. So yeah, I saw a different version of this, but I like this one better. I'm glad you found it, especially with the video of the containerscape. Yeah, I didn't look into it too closely, to be honest with you, because it seems like we're on a bit of a roll of these, both for, unfortunately, not for a single cloud provider. This stuff's tough. I think there was another one I want to get back to on this particular topic of this stuff is tough. And it might have even been we have multiple articles this week. I think probably even like the last one, the Java. Think about the people who write Java or Go or, I was looking at Julia earlier today, or any relatively, even an older language, particularly newer languages. The people who are writing these languages and contributing to them, they're pretty sharp guys, right? Guys, gals, everybody. And even with that, at Amazon, you've got let's be honest, probably some of the best people in the world doing this type of stuff. Again, they're hiring a lot of those Go and Rust coders, plus all these different languages, and it's still, an environment like Amazon, which it's known how aggressive it is to be good there, right? You don't sit on your laurels. You always have to be working at being better, and it's still there's a chance for a slip up. And I'm sure this went through review, right? They didn't just throw this code out there. This stuff is hard, and I think it comes back again to how we were wrapping up the last half hour. I was going to stick my nose in there at the end, Mike, and counter your question about what your optimistic view for the future is, and say, is there an optimistic view? And I kept my mouth shut.
I know.
And this is sort of an example of it, right? It's this stuff is hard. I don't want to say, she was talking about she didn't want people to be worried about application security engineers to be worried about their future. Yeah, you guys don't have to worry. You're good for at least 5 or 10 years. It's super complex of stuff. So especially when you start looking at containers and all the different layers and Kubernetes and blah, 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 blah. But I think that's really all I've got to say on this one. I'm glad they found it as quick as they did and it wasn't found by someone else.
Yeah, so we've got a couple more vulns, and let's actually switch to talking about some sort maybe an optimistic aspect of strategies of dealing with vulns. One is I found quite a long form, so it's a 19-minute read, but a worthwhile read about writing a Linux kernel remote in 2022. And the reason I pulled this out is that it goes in our category of it's a technical article, but a very approachable one and easy to get into. That's a junior exploit developer, someone new in their career, talking about the steps they had to go through to create an RCE for a Linux kernel exploit. In this case, this was from the Tipsy, that vulnerability that we touched on. That was announced back in, I think, in 2021, episode 173 or so. But setting aside what the actual vulnerability is, what was neat about this is walking through essentially 4 important steps, saying that we need to, a little bit of hand waving, bypass kernel ASLR. So a lot of this write-up is actually predicated on the sentiment that KASLR is pretty effective. It does make the work harder. So I'll put that into the category of it's a little bit of optimism on there, despite the fact that there are still many information leaks within and other vulns within the kernel that can leak kernel address information that can help exploit developers bypass KASLR, which is this article explains how and why they would do that. And the article is just really neat. I learned something that I have to admit I didn't realize about the context between these types of network-based remote exploits that land into an interrupt context, as meaning that here is part of the kernel that's just dealing with network traffic, as opposed to process context, which as the exploit developer you want to be in so that you can start to execute arbitrary code, get into user space, get into root execution to take over a system. So a lot of really neat things to learn if you like some C code, if you like that type of technical aspect. But I would also say, we try to also find articles that can generalize. It's a great exercise, it's a great lesson in communication, in writing through the thought process of, I have a vulnerability and I want to turn that vulnerability into an exploit. And this is just a really good way to showing the structure, showing what good writing looks like. And I'm starting to belabor the point, so let me pause there and see, John, how much of that 19-minute read were you able to get through before the show?
I did. Honestly, I just scanned it, but I think I've scanned enough of it. I think it brings back all sorts of warm fuzzies to my heart. I don't know. I was thinking sometime this weekend, I must have been talking to somebody. Like, if I wasn't doing what I was doing, or if I could go back, one of the things I'd love to do more of is vulnerability research, especially like the low-level stuff like this. I mean, it's interesting, right? It's just taking a step back and going, the idea of there's a vulnerability out there. Okay, that's not the end of the day, right? It's like, what do you do with that? How do you leverage it either locally or like in the previous story of like, okay, you've got something running. How do you get like a cloud provider to execute it so that you can get more privileges out of it, right? That's sort of a dirty thing. Or in this particular case, how do you hook a bunch of system calls to actually get, as you're just saying, from the network context over to the user context? And then what I did like is at the bottom, he had a few suggestions on how to clean up. Wow, it is sort of long. The mitigation section at the end. is neat. And people think that ASLR, well, I think it probably originally was thought of as a sort of a silver bullet to stop a lot of this type of stuff.
Right.
And I remember being, I don't know, pick your word. It was negative connotation, whatever it was. But I remember not having positive thoughts about, I think it was OpenBSD for a long time. I'm not sure if they still do. They actually disabled, they didn't have ASLR. And the thought was that the way Theo and those guys looked at it was it wasn't, worth the effort. And this is sort of, it definitely makes it harder. But there's some ways to get around it, obviously. So yeah, definitely a good read for folks that are interested in we talk about these type of vulnerabilities every week, but like, how do you make it useful to you? If you're a pen tester that wants to get above and beyond the pointy clicky thing or doing cross-site scripting or all this standard stuff, can you take something like this and actually use it to pop a box in a way that no one's expecting? I think that's pretty darn cool.
It is pretty darn cool. And if my memory serves, ASLR definitely has, quite mixed feelings within the community. And early 2021, we talked about Apple's iMessage blast doors. And if I remember correctly, part of their blast door approach was to basically reseed the randomness of the ASLR for iMessage more often than once on a single reboot. So basically meaning the implication meaning it's relatively static. Another aspect of ASLR is that if you're targeting large enterprises, and here large enterprises I'm talking about might have 50,000, 100,000 servers, massive numbers. Once you hit those large numbers, 8 bits of randomness is kind of meaningless, because you can just start, basically spraying all types of exploits, and you're just going to hit the number by luck. So there are some really interesting things to think about, but hopefully a positive story here that the defenses are slowly improving, or at least we understand what's necessary to minimize the return-oriented programming, the types of things that are bypassing ASLR. But with that, I'm going to say,
one real quick thought on that. If you think about, you had an interesting point there when you talk about especially a large busy server. The way cloud providers do their economies of scale is, if you want to figure out what type of server you're running on at Amazon, go and find the largest server that they've got, like their, I don't know, D5, X4, X5 LR. Well, their largest box they've got, and that's what you can buy. But realize, in not every case, but in many cases, if you're getting like a T2 micro, that T2 micro is sitting in one of those boxes with a bunch of other T2 micros. And that's sort of, I don't know if we've seen studies yet about what the randomization looks like on there in boxes that's busy, but these are something, it's very easy for you to get on a box that's both oversubscribed as well as multi-tenant. And it could be interesting to see how this works in that particular case.
So one last vuln, and then we're going to switch to talking about more of the defensive side. So I pulled out our 19-minute read. I think, John, you've got a 19-second read, a cross-site scripting that made you smile. Why was that?
Yeah, so I think it's a little more than 19 seconds. Let's call it 38. So, and I was talking with an old friend who, over at Hackers, that used to run the original cross-site scripting checklist. I'm like, hey, guess what? We're still going. And so what Garrett Hayes over at Portswigger was doing some research and updating their now cross-site scripting cheat sheet. And long story short, the browsers have done an amazing job of, trying to whack down a lot of these type of things over the years and, make them no longer relevant. And so he was updating and removing some of the ways that no longer work. And he found a few ways that do work. So there's two highlight. There might be three. There's three highlighted in this article. I'll start off with one relatively basic, and then go to the more advanced. So the basic one is, in a modern browser now, we have these built-in default style sheets for, what does the page look like if there's no styling on your HTML. And what he figured out is, if you're on your page, and you can do this yourself with the HTML form, as you're tabbing along and trying to get to the OK button or the cancel button, if you're trying to not use mouse, you'll see this little circle or highlight appear around that OK button. And he figured out a way to do a cross-site scripting through the transition on that highlight, which I thought is just like creative as all hell. And I think this is a story actually that got me thinking about, again, we've got some of the best people in the world working on these browsers. the browser code, and still can't stop this stuff from happening. And then the more advanced one really gave me a tickle. So we've had 2 use cases in SVG to be able to get cross-site scripting in there. And the examples are in this doc in our show notes, as usual, for folks to go and click on. But the advanced sample is within SVG, the image format, which is portable and usually text-based, so you can upload it along with your page for minimizing page and having a single load and trying to optimize performance and these type of things. Part of the SVG spec is animation. And he was able to put a cross-site scripting into the animation code, basically able to put a href and a value in there, and then have that be rendered in the browser as an image with on alert. And just the fact that you can animate a cross-site scripting into a browser, anything in a browser, just really tickled me for some reason. It's nothing. It's a little lighter. It's easy to understand, but still, it shows there's always some sort of way for folks to get through some of this stuff.
It's always, there's still a fun attack surface with an HTML, with an SVG, and all those intrinsic events sitting around, just waiting for a JavaScript payload to sneak in. Going to shift now to talking about responding to vulnerabilities and breaches, for that matter. A quick update from Okta that I wanted to highlight, in the sense of, we're talking about a lot of their problems honestly stemmed from miscommunications, or a perceived lack of transparency, or a legitimate lack of transparency, and just some confusion, ambiguity, what really happened. So their update, they explain what happened. A malicious actor accessed a single workstation for about half an hour. They sort of describe what was potentially accessible, or what could have been done with that access, and what was done. But I wanted to draw more attention to the lessons learned, because I think the lessons learned are something that any organization can look to, and one of them was third-party risk management. That's nothing surprising there. Go back and listen to our previous segment with Dr. Wang about what we were just talking about, this supply chain, for example. Access to customer support systems. This type of least privilege is a classic application security threat modeling exercise. Shouldn't be too surprising there. But what was also nice was number 3, customer communications. And this is one that definitely any organization out there can put some effort into, do some exercise on, so that if you are ever in a situation like this, unfortunately, that your response can be a little bit more advanced, a little bit more sophisticated than, we take your security and privacy seriously. So those are the 3 takeaways that I thought would be nice, worthwhile read, thought exercise for listeners.
We always need more thought exercises. Seriously, I mean, it's at least for me, I know it's like my brain dulls on either anything I'm doing, right, coding or looking at this stuff, or obviously not talking to you. But if we can take a step back and actually just think about these things without having to do action on them, whether it's if you're out for a walk or driving around somewhere or something, I think that's, at least for me, where a lot of these type of things become interesting. I thought this was cool. They gave again, good sort of, upfront description of what they're talking about, and then breaking down some things further on the page. I liked there was a section in here for developers. Where'd it go? Yeah, developer security education. And again, it's not new, but frequently, 6 or 8, 10 months from now, we're thinking through, I need to train my devs. How do I do it? If you're able to find a page like this or have it bookmarked and just come back to it in the future, that's a few very easy, quick points. It's like, hey, can we do quarterly captured flags, or hey, let's do some quizzes at the beginning of our, maybe once a month on our stand-up meetings, or maybe pass the ball around and have different people each week do some sort of a teaser on one of these forms of AppSec. There's multiple ways you can do this type of stuff, but I think this is a good overall article talking about some of this stuff. Yeah, good find.
It is, and I think it ties into some of the last parts you were just describing there, ties into the article I brought in from Flipkart. And they were describing how they approached vulnerabilities, basically issues that came in through their bug bounty program. They call it responsible disclosure. I will be a little bit nitpicky and prefer coordinated disclosure. It's less judgmental. I think it's more realistic at just describing how this worked. But that aside, what I liked about it, it falls into one of my questions, just about There is the bounty that we assign to the researchers. This is what the value was of, this is the price associated with this particular vuln. But rather than just saying we awarded that, we spent that money, paid the price for this vuln, moved on to the next one. Flipkart, they're describing how they take that particular vuln and ask the question, is this part of an attack surface that's broader that we aren't aware of? And it's really neat to see them turn an instance of a vuln into a bit of a process, a bit of an exploration to say, where else might we see this? And I think it's just a really good strategy that others, I think, have described about and approached. But this was a really neat recent write-up as well that just thought would highlight about a strategy of what does it cost to not just fix a single vuln, but the cost perhaps, and I think a worthwhile investment in saying what part of a vuln class did this bounty come in on, and can we make a meaningful difference in this particular vuln class? So actually we'll never have to deal with this bounty, this type of vuln again, or this time it was a $5,000 bounty, for example, but the next time they come through, it might only be 500 because the impact is that much lower. Or we might say the next time around, it might be 50,000, sort of because we thought this vuln class was taken care of, and we have deep pockets like the Apple, the Google, the Amazons of the world to pay out that type of bounty. So I'm trying to find some optimistic things and some strategies for the future, John. Hopefully this is a little bit of getting us on that path.
John, what say you about this Flipkart article? I'll be very completely honest and say I was looking at this when you were talking about the last one, so my apologies. This is interesting. I've already talked about it. I think there's definitely a positive spin we can put on all this stuff, right? I don't think either of us would be here if we didn't see some sort of light at the very far distance end of the tunnel. But I love actually the take you had on this. Not just the developer training, the parts I was thinking about, but every time something comes through, how do you respond to it? It's not just ongoing training and those type of things, but I was talking to someone recently. It was somewhere last year, it wasn't too recent, but we were talking about, we've talked here on the show about responsible disclosure and blameless, what's the word I'm looking for? Thank you, blameless postmortems. And these two things go hand in hand, man. It's if someone screws up, I'm not pointing fingers, I'm using an example, but someone at Amazon made a mistake about how that Java thing was coded. What did they learn from it? Have they improved their unit tests for next time? Is there a note in their code review checklist about, hey, what context is this running as? That's not a bad thing, and I doubt they're thinking. It's not a great thing, but I'm sure they are doing something like this internally too. And I'm just using that as an example purely. But yeah, no, it's something we can all improve upon. So again, good find.
I found we're running out of time, but I did find one more thing just for you, John. A write-up from IOActive. A researcher was diving into some avionics, and we actually haven't talked about anything airplane-related or space-related in quite a while. And I know we had a bunch of that. So here's a good technical article that, again, might be of interest to listenerships who are flying their own planes, perhaps. I'm not sure how many that may be, but others, of course, just with a sense of a technical curiosity and want to read and just understand what is the attacker-minded thought process as they look to see, here's a problem, here's a device, hardware, software, I want to pick it apart. And again, it's just really good to read through these types of articles to get that mind thinking and to understand how do other people approach these types of problems and what are some ways of thinking that I can take from that and apply to my own whatever challenges they are.
Yeah, unfortunately, I didn't read this. I'm going to read it now because this stuff does give me tickles. So just quickly scanning it through, it looks like he had some fun with this. But even for folks that are, you don't care too much or you're sort of high level on this type of thing. So this is the flight control system for a pretty decent sized business jet. Just saw it in front of me, a Bombardier Challenger 604. So that's a fairly large jet, man. That's people listening to the rap music out there might think of G4s and G5s. This is probably the same as a G3 or G4, so it's a decent sized plane. And just what goes on behind the scenes, what's going on in here, and what is the security state of it. So definitely worth a read. I mean, it's funny to bring an example for this. Let's sort of tie some of this stuff back. someone on Discord was talking about, oh my God, 2022, we're still talking about patches. So
Yeah.
for me, I've got an app on my phone called, there's two, but the one I'm thinking of right now is 4Flight, which is what's called an electronic flight bag, or it can be called an electronic flight bag. So that has all your charts and routing and planning and up to date, either where fuel is, what the flight restrictions are, all this type of stuff. But that is considered, is FAA certified EFB, which means that every time there's a new version of iOS comes out, if I was flying with that, particularly professionally, I would have to wait for the company to come out. They do this usually within a week. They'll say, hey, we've tested the software with the new version of iOS, it still works. And that's just for an iOS app. So you can imagine what goes on for the stuff that's running in this article. The testing is crazy compared to what we're usually used to. Makes the things very expensive. But this is sort of a great walkthrough of what's actually going on underneath those scenes. So yeah, that'll be a fun one.
It'll be a fun one. And John, unfortunately, it's time to bring this episode in for a landing. So I do want to say thank you for walking us through the news. Thank you to everyone hanging out and chatting with us in Discord. Thank you, of course, for everyone who's a listener. Also, another thank you to Johnny, our engineer behind the scenes, who keeps everything running smoothly. This is his last show with us, and we're grateful for all the work he's done on our AV quality. Please subscribe, give us a like for this good quality that Johnny's done for us. Check out the show notes. And speaking of Johnny, check out the Midnight. It'll make him happy. And with that, we'll see you next week on Application Security Weekly.